Good evening, everybody, and welcome to a new episode of vBrownBag. This evening, we are going back to AWS. We've brought with us an AWS hero, the illustrious, the amazing, the easily pronounceable last name of Luc van Donkersgoed. Hey, Luc, how are you doing?
I'm good, thank you. How are you?
We are doing fantastic. So, folks, this evening we are going to be building cloud native apps with serverless integration testing. This is something that it's new-ish to me, so I'm going to have some dumb questions, but it is old hat for Sean Doyle, so he's going to have some smart questions. Sean, how are you feeling this evening?
Doing great. Yeah, excited about this conversation.
I noticed that you are not in your usual place. Are you on vacation? Am I jealous?
I am on workcation, so I am took my family on a vacation, but I am working. So,
well, bless your wife's heart for letting you do a workcation like that. Awesome. Cool. Okay. Well, before we get into the meat of this, let's go through some show notes. If you want to get in on the conversation, please feel free to @vBrownBag. We are paying attention to the Twitter sphere. You can either @vBrownBag or #vBrownBag. And both Sean and I will be paying attention to any questions that come in, and we will pose them to Luc and also leave them there for future posterity. So feel free to post them in the future as well. Once again, his name is Luc van Donkersgoed. He is an AWS hero. He is very intelligent, and his Twitter handle is Donkersgood, not G-O-E-D, G-O-O-D, because he's good. I highly encourage you to follow him on Twitter. He's got some really fantastic posts and a slew of good information. And if you want to, you can also follow me and Sean. We are respectively Mistwire and Cloud Osmotic. Our material isn't nearly as fun. Mine's mostly cat pictures, but Sean's got some good stuff too. So give us a follow as well. Luc, I am going to stop sharing and give you the power. Are you ready?
Yeah. All right. Here we go.
Awesome. I can see your screen.
All right, thanks. So yeah, today we will talk about confidently building cloud native applications with serverless integration testing. And well, as the title implies, today's talk is all about testing and serverless. But before we dive into the main topic, let me introduce PostNL. So PostNL is the largest logistics company in the Benelux. In 2021, we delivered an average of 1.2 million parcels per day and 8 million letters per day. And PostNL is on a mission to become a tech company. So we're moving from being a logistics company that uses technology to a company that builds technology to do our logistics. And we have a full AWS serverless mandate, which means that all applications built by our in-house development teams must be completely serverless. And of course, many, if not all, of the applications we build are mission critical. They control the sorting lines and the delivery routes. They power customer-facing websites and applications. And if these applications break, then a large part of the Benelux might not receive their shoes, electronics, or books. So reliability is extremely important to us. And one of the most important tools to guarantee reliability is automated testing. But the testing landscape for serverless applications is significantly different than the landscape for EC2 or container-based applications. So, well, as Chris introduced me, my name is Luc van Donkersgoed. I'm the lead engineer at the PostNL integration team. I'm also 12 times AWS certified and AWS hero, and I write articles about AWS serverless on bitesizeserverless.com. And today I want to talk about the importance of unit tests, but also why we can't use unit tests in a serverless environment, and the solutions we designed at PostNL to fill this gap. So first, let's take a look at the famous testing pyramid. It's used in classic software development to indicate the relation between unit tests, service tests, and end-to-end tests. And one of the most important distinctions in the pyramid is that most of your tests should be unit tests. And that's because they run fast and they run offline, and they provide very granular insight into what works and what doesn't. So in other words, they provide a very short feedback loop. So here's an example of a few unit tests running on an application. They test a specific function or a small collection of functions, and they test happy paths as well as unhappy paths. And as you can see at the bottom, these tests execute very quickly. So in this example, 4 tests were completed in 0.02 seconds. So unit tests run very quickly. They provide short feedback loops. They offer great granularity, and they really test the implementation details, the innards of your application. And this is also called open box testing. Now, one step higher in the pyramid are service tests. And these also perform happy paths and unhappy paths. But instead of the open box testing of unit tests, the service tests test the service as a closed box. So they know nothing about the internal workings of the application, and they only verify that the integration points, for example, API endpoints, behave as expected. So contrary to unit tests, service tests run against a deployed service. So a service needs to be deployed before tests can run on it. The tests themselves are more complex than unit tests. Service tests only check the integration points. And generally, because of all of this, the service tests take a few minutes to run. And because of this, the feedback loop for service tests is a lot slower than for unit tests. And the insights provided by service tests is a lot less granular. Now, the top of the pyramid are end-to-end tests. And these verify that multiple services work well together. An example would be a payment and a loyalty service, where the test performs a payment and then verifies that the loyalty points associated with the purchase are added to a user's account. Now, end-to-end tests are the most complex to build and to maintain, and they have the slowest feedback loop. So they generally take a few minutes, but they can even take up to an hour to run, depending on their complexity. And of course, they provide the least granular insight. So if an end-to-end test fails, it's really up to a developer to spend the time to find out why the test failed. So with the basics out of the way, let's look at what this means for serverless environments. A commonly heard mantra for serverless is code is a liability. And this is a bit tongue-in-cheek, but there is some wisdom in it. Because what we mean when we say code is a liability is that if AWS or any other public cloud provider offers a managed service, they will literally run and maintain it for us. They will monitor its performance, they will scale its underlying instances, and they will patch its libraries and operating systems. When we write our own code, all of that responsibility lies with us. And this is true for network-based technology like load balancers and RDS, but it is especially true for serverless services like S3, DynamoDB, or SQS. I mean, who is still going to write their own queuing software when you can just use the almost infinitely scaling SQS off the shelf? So a non-serverless application might look like the one on the left. There's a load balancing component, a user component, there's a queuing component and a mail component. And all of these components are built and maintained by your developers. It is code that you own. And you own the integrations and the integrations between the components as well. Now, the same application in a serverless environment might look like the one on the right. So it has an API gateway, Cognito for user management, SQS for queues, and SES for email. And to build this serverless environment, we just link the services together through configuration and infrastructure as code. And the configuration and integrations are the only thing that you own. Now, of course, I'm comparing two extremes, but they do drive home the point I'm trying to make. And that point is that the solution on the left contains a lot of code that needs to be tested and maintained, while the solution on the right contains no custom code at all. It only contains integrations. And the left side has a lot of unit tests, which provide fast feedback on the application state, while the right side has no unit tests at all. So let's look back to the 3 types of tests in the testing pyramid. We have the unit tests, which provide fast feedback and granular insights. We have service tests, which test the outside of a service. And we have end-to-end tests, which verify that multiple services work well together. Now, in a serverless environment, there are only a few unit tests anymore, which test the internals of any Lambda functions that we might have. But it's really only a fraction of amount of the unit tests we would have in a non-serverless environment. We do still have service tests and end-to-end tests, but again, these are closed box tests. They don't test the inner workings of our applications, and they have longer feedback loops. So this leaves a gap in our testing coverage, because how can we still have the granular insight and the fast feedback, but then on a serverless application? Now, our answer to this missing piece in the testing landscape are cloud-native integration tests. And these tests run against deployed serverless components, such as API Gateway, SQS, or Cognito, and they verify that these services are individually configured correctly. And we recognize 2 types of cloud-native integration tests. The first are cloud-native integration tests, which verify if our application integrates with AWS the way we expect. For example, an API gateway might be configured to use IAM authentication, and our integration test should confirm that an authorized IAM principal can call the endpoints, while an unauthorized IAM user is blocked with a 403 error. And the second type of cloud-native integration tests are those who verify that 2 services work well together. So an example would be an SQS queue and a Lambda function. And the integration test should verify that when we put a message on SQS, that the Lambda function is triggered and leads to the successful execution and successful result. So cloud-native integration tests really sit between unit tests and service tests, because unlike unit tests, they run against a deployed service. But unlike service tests, they test specific components. So they are open box tests. And that leads to the new testing diamond shown on this slide. So now that we know what to test, let's take a look at how to test these integrations. The first thing we need is the ability to call specific components in our service. After all, we want to achieve open box testing with granular insight. So in the architecture on this slide, this means that the test will need to be able to call API Gateway, to check CloudWatch logs, to invoke Lambda functions, and to read from the SQS queue. And all of these actions means that the testing service or framework needs to know about all of these components, and it needs permissions to access them. And this makes a very strong argument for hosting the testing framework in the same AWS account as the service being tested. Because an external service would require very broad permissions and cross-account or cross-internet access to your service, which would be difficult to configure and audit. Now, luckily, the AWS serverless landscape offers a great tool to execute arbitrary functionality, such as tests, with a very granular permission system. And you might have heard of them. They're called Lambda functions. And we can actually use Lambda functions to call one service and then check another service for the expected result. For example, a Lambda function can call API Gateway and then check if the access logs contain the expected entry. This verifies that API Gateway access logging has been set up correctly and that API Gateway has the required permissions to write logs to CloudWatch. Now, I'm hearing you think that's a lot of custom code to maintain again, because all of those tests need to be written too. And weren't we working to remove custom code as much as possible? And you're right, but there are a few arguments why custom testing code is different from custom code in your production systems. And the first is that tests are always bespoke code. there will never be an off-the-shelf solution that perfectly matches our use cases. And the second reason is that there are very powerful and reliable testing frameworks that do most of the heavy lifting for us. So in JavaScript, for example, you have Jest. And on the next few slides, we'll look at a few tests written in PyTest. And the third argument why custom testing code is different than custom code in production is that the testing code is outside of the production loop. So customers will never interact with this code. So access patterns and performance are less important than code running in your production systems. All right, so let's take a look at a test written in PyTest and running in a Lambda function. Our first use case is an API gateway configured with a request validator and a custom response. We expect that a valid request returns a 200 response and a simple JSON response body. And as you can see, we're using the AAA pattern. First, we arrange the test, then we act, and finally, we assert that the result matches our expectations. There are no resources created as part of this test, so we don't need to do any cleanup. And the previous test covered the happy path, but of course, we also want to validate that an invalid request returns the expected 400 error and the correct response body. And the test displayed on this slide sends an invalid payload to API gateway and then validates that a 400 error is returned. And the previous two tests validated that our API gateway as a standalone service was configured correctly. But now let's look at an integration between two services. And in this case, we want to guarantee that any API call results in an access log entry in CloudWatch logs. So we call the API gateway with a known good payload again, and then we read the CloudWatch logs to verify that our 200 access log line is present. And then we do the same, but with an invalid request again, and then we verify that the 400 access log line is present. Now, this test looks a lot like the previous tests, but this time we use the request ID to find a log in CloudWatch instead of looking at the response code and the response body. And you might say that these two tests, the one looking at the response and the one looking at the access logs, could have been merged into one. But remember, we're looking for granularity. So by splitting it into tests, we can pinpoint exactly what goes wrong and what went well. Now, in this example, our Lambda function needs permissions to read from CloudWatch logs. And by applying the principle of least privilege, that's also the only permissions that this Lambda function will get. And that brings us to the next topic, which is scaling the tests. Because for any significant application, there will be dozens or maybe even hundreds of integration tests. And putting them all in a single Lambda function would break the principle of least privilege, because a single function would need access to all services. And also, PyTest is a single threaded application. So all of the tests would be executed serially, which would lead to very long execution times. And the solution is to create a testing function per tested component, also called the system under test. And this function only needs permissions for its own scope, and all the different Lambda functions can be executed in parallel, which leads to much faster executions. And the Lambda functions themselves simply run the PyTest test scripts that we saw earlier. So the next question is, where do we store these tests? Well, just like unit tests, we store them as part of our CDK project. And on this slide, you can see our test directory, which has an integration test subfolder. And that integration test folder contains a directory for each testing Lambda function. And each Lambda function has a number of test classes, which can be recognized by their test underscore prefix. And the test underscore prefix is actually used by PyTest to identify test classes, and they will be used to build up a test suite. So as these files are being discovered by PyTest, PyTest will look inside the file, and in the file it will find a large number of functions. And any function prefixed with test underscore is considered a test case, and will be executed as part of the test suite. So these tests are executed by our Lambda functions. But there's more. Because the tests follow the default PyTest conventions, we can run these tests from our local machine as well. And that might look a bit like this. This is the exact output of the tests running in PyTest on my local machine. The tests run locally, but they actually test the components deployed in my sandbox AWS account. The only thing required to make this work is administrator access to that account, which is generally no problem for sandbox accounts. So let's see that in action. In this short clip, you can see the tests running on my local machine. You can tell that they are a lot slower than unit tests, but still this is a very short and very valuable feedback loop. And the tests being executed look like the code on the left, as we saw before, and the API being tested is part of the architecture you see on the right. So now we've seen how to run these tests locally. And this helps us build features and helps us verify everything works even before we create a pull request. But we also want to run these tests in an isolated environment as part of our quality assurance process. So we've seen how these tests are distributed across many Lambda functions. So how do we orchestrate all of these functions and process their results? Well, when somebody says orchestration, your first response should be step functions. So that's what we'll use. And on this slide, you see the integration test state machine with a single parallel state. And the parallel state contains all the testing functions. It collects the results from each of these functions and then generates a test report. Any test function failures, such as timeouts, execution errors, or out-of-memory errors, are caught by the parallel state as well and forwarded to the test report too. Now, the main goal of integration tests is to validate that new functionality in our service works as expected and to make sure that existing functionality does not break when new features are released. So a good time to validate these goals are achieved is at the moment of pull requests, because PRs can trigger any kind of automation, including full deployments of our environment to an AWS account, and they can trigger the integration tests that we saw on the previous slide. Now at PostNL, we use GitHub Actions for our CI/CD process. And as you can see on this slide, we have configured our GitHub Actions to first deploy our service, then start the integration test, and then wait for the integration test to succeed. If all tests succeed, then the pull request can be merged. And if any integration tests fail, it can't. And when the tests have completed, the entire stack is torn down again, leaving us with a clean state. Now, the CI/CD integration does require a few extra components in the state machine. So the steps added to the top and the bottom of the workflow are used to communicate the test status back to GitHub. And the first one will set the GitHub check to pending. And the bottom one will report either success or failure back to GitHub, including all of the execution details. Now, a real-life example of these reports on GitHub looks like this. So on the top, it states that 23 out of 23 tests passed. And in the middle section, it shows a list of all of these successful tests. If an integration test fails, then the entire output of the failed test is included in GitHub, including the assertion that failed. So in the zoomed in area here, you can see that a Lambda function returned a 500 error, while a 200 response was expected. In this example, this was caused by an updated dependency, which is exactly the kind of error we're trying to catch with our integration tests. So let's recap. First, the old testing pyramid heavily focuses on unit tests. In a serverless environment, we aim to replace most of the custom code with managed services. And this leads to a reduced importance of unit tests, but it also leaves a gap in our testing coverage. And this gap is filled by Cloudnative integration testing, leading to the new test diamond. Cloudnative integration tests are best run in the AWS account hosting the service, which allows the test to directly interact with the AWS services under test. Lambda functions and a testing framework like Jest or PyTest allow us to focus on the test details, while the heavy lifting is done by the framework. Orchestration of tests is achieved through step functions. And we integrated these state machines into our GitHub Actions pipelines, but with a bit of custom code, any CI/CD pipeline, including GitLab, Jenkins, or even Azure DevOps, could use this better. And with these tests in place, our serverless mission-critical applications can be delivered to production, both quickly and reliably. And this allows us to deliver your parcels, both quickly and reliably. And that's it for me. So back to you, Chris.
Luke, that was absolutely amazing. So I have hundreds of questions, but I've written down a list of all the things that I need to Google so that I can get smart enough to be able to pose the questions to you because that was fantastic. That was a massive amount of information. You showed me things I didn't even know that PyTest could do yet. Sean, is there something you want to extract from that? Because I have like 17 hours of Googling that I have to do before I can even respond to that.
Yeah, no, I was pretty excited when you brought up the orchestration piece with step functions. I'm a huge step functions fan. And like you said earlier, right, code is a liability. And I mean, even with step functions, we can take out some code instead of having to write custom, instead of having to have your serverless app manangle the data to send an SNS notification, you can just have step functions send an SNS notification. You don't have to write that code to call the API, just have step functions do it, passing the payload back. So I was like, is he going to bring up step functions? Is he going to bring it up? Is he going to bring it up for parallelization for that? And then I'm glad you did, because I think that's really something exciting to see. And I really thought it was exciting that you had that kicked off by GitHub Actions and have that generated test report come back. Like, that's really, really cool. I'm looking, I've never thought about using it like that. That's interesting.
Yeah, we're really happy with that integration for our work, because now it's just part of our GitHub pull requests, and there's no chance that somebody forgets to do the integration test or whatever. It's all automated. You just start the pull request, you go get a cup of coffee, you come back, and you see all the results right there. So it works really well for us.
I can tell that Sean's excited about it.
Yeah, sorry.
Go ahead, Sean.
So how do you, so you have your integration tests in Lambda that's calling the services as a unit, right? So you have your API gateway Lambda tests, and you have your SQS or your Cognito tests that are all orchestrated through step functions that are orchestrated through GitHub Actions. So the repos that, it's sort of like these layers of inception. So like, where do the repos live for the API gateway tests? Are those also on GitHub? Are those in code commit? Are those closer to AWS?
Well, it's actually, it's part of the CDK project. And actually there's like 3 levels of abstraction, because we have the Lambda function running PyTest. So that's an abstraction that goes into step functions state machine. So that's an abstraction, and that goes into GitHub. So it's 3 levels. But we actually have those integration tests and the state machine as well as part of our CDK project. So it's part of our standard code base, like you would do with unit tests. But you have to deploy them. And well, we have some like environment variable magic where we make sure that the integration test infrastructure is only deployed to our dev and test environments, and it's not included in our acceptance and production environments.
I see. Okay, that makes sense. So it's all written in the CDK, and it's bundled alongside your actual application code.
Yeah. And actually, that has some really big benefits, because that way you can actually do references from your integration tests to the actual resources that you deployed. So for example, you might have an API gateway with a certain domain name or a Lambda function with a certain ARN, but we can just reference that from our testing Lambda functions. And then if it ever changes, we don't need to update our integration test.
Very good. Very interesting.
Nice.
So yeah, a few things I couldn't include in the presentation, but a question that I often get is where does CDK testing, like assertions, fall into this pattern? Because you can do offline testing in CDK, and you can just assert that certain resources are there. That's true. But the reason we use those as well, but the reason we don't completely depend on those is that it doesn't actually verify that it works in a deployed environment, right? Because there might be an IAM permission that's just not exactly right, or there might actually be like service control policies or other limiting factors in your AWS account that you're not testing offline. And then the response I often get to that is, but you can also do end-to-end testing, right? And then you actually test the deployed service. And that's true, but that's then missing that granularity where you can actually pinpoint what exactly works and what doesn't. And also end-to-end tests only test the outside, right? So for us, from an audit perspective, it's super important that we have CloudWatch logs for our API gateway access logs. But an end-to-end test can never verify that because it doesn't have access to those logs. It's because it's a closed box. So, so yeah, that's how we came to this solution.
Nice. I was going to say that I can tell Sean's excited because we're actually Sean and I are chewing on a problem internally at the place that we're at right now. And I got a couple of ideas from this presentation for some things that might be helping us along the way too. So I'm very excited about this.
Oh, good to hear. If you have any questions at a later time, just you know how to reach me, right?
I 100% will. Absolutely. Cool. Well, Luc, thank you very much for coming out and doing this presentation with us, and for being flexible and doing it in this guerrilla podcast out of band style that we're doing it in. So thanks everybody for attending, and we'll see you again the next time.
Thanks, Chris. Thanks, Sean.
Thanks, Luke.